Okay, good afternoon, students. So this video is for class 10. Okay, class 10B. So the exercise that we're doing was exercise 21E. In the previous lesson, in the previous class, we have finished till question number 1, page number 332, question number 1, part 14 or part 16, which is last question, okay, of question number 1. And now here today we're starting with question number 2. The question goes like this: given sin A plus cos A is equals to P and sec A plus cosec A equals to Q. Okay, then we have to prove that Q bracket P square minus 1 is equals to 2P. We have to prove this. Okay, left hand side is equals to right hand side. Okay, given by this two conditions. Using these two conditions, we have to prove left hand side equals to right hand side. Okay, let's go to the given condition once again. The given condition is that given sin A plus cos A is equals to P and sec A plus cosec A is equals to Q. So small p and small q, the values are given out here, this and this, and we have to prove it as left hand side to right hand side. So in the left hand side, let's focus on the left hand side what we have. Okay, left hand side is P Q bracket P square minus 1. So I'll find the value for this and I'll find the value for 2P. If they are equal, then left hand side is equals to right hand side. Okay, so how will I find the value for left hand side? Put the value for Q, put the value for P, minus 1, solve it. Let's start. Okay, left hand side, LHS. So LHS, we have Q, P square minus 1. So Q, what is the value for Q? The value for Q is sec E plus cosec E. Close the bracket. Now I'm opening a curly bracket because it's P square. The value for P is within the bracket sin A plus cos A whole square minus 1. Clear? Okay. Now, so I cannot do anything with this sin and cos, sec and cosec. So keep it as it is. Sec A plus cosec A and into. Now what we can do here is we can expand this using the formula of A plus B whole square, which is A square plus B square, right? A square plus B square plus 2 and then A into B minus 1. Okay. So another thing what we know is we also know the value for sin square A plus cos square A. Using the square relation, it is 1. And this 1 and minus 1 will be cancelled out. So sec A plus cosec A, okay. The value for sin square A plus cos square A is 1 plus 2 sin A into cos A minus 1. So plus 1 and minus 1 gets cancelled out. So therefore this is sec A plus cosec A. Since plus 1 and minus 1 got cancelled out, so we are only left with plus 2 sin A into cos A. So I can simply write 2 sin A into cos A. Okay, but I have to prove it as 2 into P. So the value for P is sin A plus cos A, which I'm not getting out here right now. Okay, so therefore which is equals to, write 2 sin A into cos A, right, into sec A plus cosec A. Sec A plus cosec, SEC, cosec A. Okay, so write down 2 sin A cos A into, we know the reciprocal formula which we have learned. Sec means 1 by cos, and then cosec means 1 by what? 1 by sin, isn't it? Okay. So again, focus on this bracket. So 2 into sin A into cos A into, let's take the LCM. The LCM here is cos A into sin A. I hope you are getting it. Cos gets cancelled out, so it is sin, and then sin gone. This is cos. Okay, since it is in the denominator, multiplication sign in between, so I can easily cancel cos, sin, numerator denominator gets cancelled out. We are left with 2 sin A plus cos A. Put the bracket, don't forget the bracket. Okay, so 2 sin A plus cos A. What was the value for sin A plus cos A? according to the question, sin A plus cos A is equals to P. So therefore, hence it is nothing but 2 into P, which is 2P, which is our right hand side. So hence we have proved. Okay, I hope you're clear with this. We move to the next one. Okay, so next one is question number 3. The previous one was question number 2, which we have solved just now. We are heading to number 3. Number 3 and then number 4. Okay, now see, I'll just give you a hint out here how to solve question number 3. Okay, let's read the question first. X is equals to A cos A and Y is equals to B cot A, and we have to prove this relation. Okay, left hand side is equals to right hand side. So how will I start with? First is okay, I'll just write the question and give you the hint. Okay, right. Okay boys, so here we are in question number 3, page number 332. Given x equals to A cos theta, y is equals to B cot theta, and we have to prove that left hand side is equals to right hand side. Please follow the questions on your book, page number 332. Okay, so now I need to prove left hand side is equals to right hand side. Look at the left hand side. We have A square by x square minus B square by y square. Okay, just forget about the square. First I need to get the value for A by x. And how will I get the value for A by x? Using this first condition, x equals to A cos theta. So let us write down here, x is equals to A cos theta. So therefore, which implies x by A equals to cos theta. Okay. Similarly, y is equals to B cot theta. So the value for y by B is equals to cot theta. So this much is what we get from the given conditions, x by A, y by B. But on our proof, in the left hand side, we need to prove that A by x, just the opposite of x by A. So I need to flip it. Okay, so once I take the reciprocal, A by x, the right hand side also will be just the opposite of cos theta, is 1 by cos theta. Similarly, when I flip this side as well, I get B by y, which is 1 by cot theta. Okay, and from the reciprocal relation, what we know is 1 by cos is nothing but sec theta. Let us keep it inside the box. Okay, and similarly, B by y is equals to 1 by cot. So 1 by cot means 1 by cot is tan theta. We know this relations. Okay, so now things are going to be very easy for us. We will just substitute these values in the left hand side. Okay, so LHS, we have E square by x square minus B square by y square. I can write this as A by x whole square minus B by y whole square. The value for A by x, sec theta whole square minus tan theta whole square. So therefore this is sec square theta minus tan square theta, which is equals to 1. Hence the proof, this is my right hand side. So therefore LHS is equals to RHS, which is your proved. Okay, so this is your question number 3. Okay, question number 6. Now we are moving to question number 6, part 1. Given that if 2 sin A minus 1 equals to 0, then prove that sin 3A is equals to 3 sin A minus 4 sin cube A. We have to prove this. Okay, so from the given, first, as it is given that 2 sin A minus 1 equals to 0, we'll first find the value for sin A. So 2 sin A minus 1, take it to the right hand side, it becomes plus 1. So therefore sin A is equals to 1 by 2. So this is the value for sin A. Okay, and we also know sin A, sine of which angle is half? Sine 30 degree. So sine 30 degree. So what is the value for A then? So the value for A is 30 degree, removing sine on both the sides. So the value for A is 30 and the value for sine A is how much? 1 by 2, which is half. So these two values are very important for us to prove left hand side equals to right hand side. Okay, now we'll start with left hand side. So left hand side, it is sine 3a, sine 3a. So sine 3, what is the value for A? 30 degree. So put the value out here. So sine, this becomes 90 degree. We know the value from the trigonometric table. Sine 90 degree is equals to 1. So hence on solving, we got the value for the left hand side as 1. Now we'll do the same thing with the right hand side. Okay, and we'll check the value for the right hand side. If it is 1, then LHS equals to RHS. So I think so I'll do it here. Okay, then right hand side, RHS. So RHS, the expression is 3 sine A, right, minus 4 sine cube A. So 3, the value for sine A, 1 by 2 minus 4, the value for sine A, 1 by 2 whole to the power 3. So this is 3 by 2 minus 4 into 1 by 8, we know it, because 2 cube is 8, 4 ones are 4, 4 twos are 8. So 3 by 2 minus 1 by 2, the LCM here it is 2 as well. After taking the LCM, it is going to be 3 minus 1, which is 2 divided by 2, which is equals to 1, which is my right hand side. So clearly here, you can write down here, you can see right hand side is equals to left hand side, which is proved. Okay. Now I want you people to try as well as question number 6 part 2. Here will be your homework. 6 part 2 you will do it as homework. 6 part 2 homework, and then we move to question number 7. Question number 7 part 1, evaluate. By the way, this question is 2011 ICAC 2011. Okay. So the question is 2 bracket tan 35 divided by cot 55 whole square plus cot 55 by tan 35 degree whole square minus 3 sec 40 degree divided by cosec 50 degree whole square. Okay, so basically this type of questions we have already done in class 9 also. These questions are based on complementary angles. If you just look at the angles, 35 plus 55 90, 55 plus 35 90, 40 plus 50 is also 90. So any of the two angles we can change by using complementary angles. We should be knowing the formula. Okay, now 2, since it is 90, the sum is 90, I'm just going to change either tan or cot. So let's change 35. Okay, so I'll write 35 as 90 minus 55 divided by cot 55 and then whole square. Similarly, cot 55 as, I'll write cot 55 as 90 minus 35 divided by tan 35. Okay, and the final one minus 3 sec 40, we can write it as 90 minus 50 and divided by cosec 50. Okay, so now we know the formula. Tan 90 minus 55 is cot 55, cot 90 minus 35 is tan 35, sec 90 minus 50 is cosec 50. Everything gets cancelled out. Make sure that there's a whole square out here. Okay, so 2 within the curly bracket, tan 90 minus 55. Use the formula. Tan 90 minus theta is cot theta. So cot 55 divided by cot 55. Okay, whole square plus this is tan 35 divided by tan 35 whole square minus 3. This is your cosec 50 by cosec 50 as well. Clear till here? So everything gets cancelled out. This also gets cancelled out. This also gets cancelled out. This is 2 1 square plus 1 square minus 3 into 1. So 2 into 1 square is 2 plus 1 square is 1 minus 3 square. 3 into 1 is 3. So 3 minus 3, which is equals to 0. This is the value. Okay. So your homework for today will also be question number 7 part 1 and then 7 part 2. So tomorrow I start from 7 part 3 onwards. Okay boys, so go through this properly and then practice hard, practice it properly. See you in the next one.